For question number 3, which is a joint distribution question, where waste disposal chute and the trash is falling through that. The trash either goes through the right bin or the left bin. It goes to right bin probably 3/4 and goes to left bin maybe 1/4. Right bin can hold to 3 pieces of trash and left bin hold to 1 piece of trash. You also will block off the chute once one of the boxes is like full. So determine the sample space, like what are the possible sample spaces, or like what are the possible ways the trash can fall through. So the first one is if it first goes to the left bin, and then first one of my boxes is full now, I'm gonna block the trash chute. Then another possibility is that it first goes to R, then it goes to N. Then I have to block off my trash chute again. Now, if it first goes to R, then it again goes to R, and then L, another try. Then I have to the shoot again, and then if I go from R, 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 now that my R1 is full, I have to block my shoot again. So this is the space. Probability of each one of these is basically what are the chances that I go to left and fourth? What are the chances that I go to right and then left, which is just 3/4 times 1/4. Because we have independent limits, I can just multiply them, which is 3/16. Probability of R, then L is 3/4 squared times 1/4, which is 5/64. The probability of R is 3/4 7/64. Part B is asking us to find a joint distribution for L and R. What I mean by that is this is the probability of them individually happening. So when is R going to be 0? Or when is R going to be 1, 2, 3, and 0, and 1. So we both know that in the sample space, there's no way that I don't put a trash. So the possibility that R is also 0 and L is also 0 is just 0. Also, other ones also don't happen. So this one is also 0, this one is also 0. But this does happen that R is 3 and L is 0, which is this one right here. The probability of that happening is 27/4. Then we know that L1 happens with 1/4 probability. This first one right here. L1 and then R1 happens with 3/16 probability, which is right here. L1 and R2 is going to happen with 9/64, which is right here. And then this also cannot happen. Now we need to find the marginal distribution, which is basically we just add. So let's say, for example, I'm trying to find marginal distribution for L is equal to 0 and L is equal to 1. So I'm going to add all the probabilities for when L is equal to 0, which is the first row here in part B. So it's just 27/64. And then if I add second row, which is L is equal to 1, I'm going to get 37/64. Like adding 1/4, 3/16, and then 9/64. Similarly, if I want to do for R, which is going to range from 0 to 3, I'm going to be adding this value, so 1/4. And this value, which is 3/16. Like this whole row is basically not the value, but just because the row only has those values, it doesn't have to be similar. Part D, we need to find out if they're independent or not. And then as you can pretty much tell that for some value of R and L, they both will not be the multiplicative of that. So let's say if probability of